T is another one which integrates very well with that, and these are the two that we use. So here, whether you like it or not, I don't like it very much, but I've sort of learned to live with it. In this particular instance, we are into coding. We are into writing pages in JavaScript. Having said that, once they're there, they're there. I mean, the tough bit is getting it up and running and getting the configuration you want. Once it's there, there's really not too much that has to be changed and configured. And there are some alternatives to that. I've not used them very much, but I think there are things coming along which are going to make the JavaScript side of things easier. So we end up with a nice map and a happy user, hopefully. Content.js, again, that's the sort of utility tool. It would be wrong to, it doesn't the formal part in this process, but it would be wrong to omit it because it's something that we use all the time as we go along for just seeing what data looks like. So maybe doing some styling, playing with that sort of stuff. So it's part of the picture without being sort of part of the process, if you like. So just to summarize on the publishing side, this is our storage in PostGIS, this is our delivery phase in GeoServer, and this is our publishing phase in JavaScript pages, OpenLayers, GeoEXT. So the application grave, give you just refresh it. So this is a housing association in Newcastle under Lyme, as you can see. We've simply taken this energy-related data, we've color-coded it, we've aggregated it to a couple of levels, their postcode level, and to their neighborhood level. These layers can be switched on and off. We've also got the property level, which obviously is not so difficult to see at this layer, but at this level of zoom, you can zoom in. And you can see, I don't know how much, I don't want to go too much technical detail, but you see that as it loads, what's actually happening is that we're generating tiles, so we're generating images, which is what makes up the website. The images are being generated from the data in the database by GeoServer and sent to the browser. So that's the way that the browser can interpret it. It's really the same way as Google Maps or Bing or whatever else works. So it's something called WMS, Web Mapping Services, which provide that. And this is a pretty standard way of working in web maps. We've got the database behind this. So if you want to look at the data, if you want to look at the data that underlies this, we've got access to it. So the idea really is that you provide a nice interface that people can browse around, that they can, that they can see what's there, see what isn't there, take in the styling. The styling we've got here is pretty simple. It's just a sort of binary thing, whereby if a value is less than a certain amount, it's red, and if it's more than a certain amount, it's green. But behind that, we've got the data, so that we can make a call to the database, pop up any data that's sitting in the database for that particular property, or for that particular postcode, or for that particular neighbourhood. And we can put styling on that as well. So we've got some styling in here again, which says fuel poverty. If it's fuel poverty index, for example, if it's less than 10%, you make it green. If it's more than 10%, you make it red. So that's all done dynamically, so that the data in the database changes. We don't change anything. It's just displayed to the user in that form. What else have we got? We've got index of multiple deprivation data here. So we've got an overlay, which it's not very pretty colour to design. It's not my forte, but we've got a legend. So they can look at these are lower level super output areas, I think, and they can say, okay, well we want to focus our efforts this year in those areas with the highest index of multiple deprivation. Let's look at the colours. That's off when I've worked out how to make them a bit more sort of web friendly. and we'll focus our resources there this year. And the legend, by the way, is automatically generated from the start. So that's part of the package. I haven't had to spend time on this. Laboriously putting together some legend in HTML when we pull that up. So that comes with Geosurveying. The other thing we've got here is the ability to do some filtering. So we can say, okay, let's have a filtered property layer, and let's show all the properties where the SAP is less than 50. And that's making a call to the database, running an SQL query, sending it back, showing the results, and say let's go low, look at the really rubbish ones. That's our miscreant where the SAP value of this property is less than 20. This needs to be a priority, and that currently is. Maintenance program, or dig into the detail of what's going on. Is it the boiler? Is it the installation? Is it what's the issue there? So this is still in beta, and we're developing it as we go. So the intention really is to just build in a bunch of filters here, which will allow people to make queries, pull the data out of the database that they're interested in. We've got different base layers here. We've got the big area, and we've got time grid and so on. So we've got the ability to put in whatever base layers we need. So I think that's probably the extent of the demo. Zoom in. It's the usual kind of. We're trying to keep it fairly simple because we want something which people can use, can be embedded in people's intranets. It's not necessarily give anybody the genes and they turn it on. So let me get back to so summary. I mean, our strategy really is this. The important thing I think is to get a platform up there which you can build. And what we like about this platform is that we've got it up there. It's pretty straightforward to publish new data now. We've got a throughput a workflow which means that I or other people with the right skills and documentation, but it's not a sort of rocket science job, can upload a file, do some styling, make it available, and then it's available to everybody. So provide a platform, populate it, and then just keep refining and developing it, and allow it to be something where it's a dynamic artifact that can be used and developed as people wish. If you get to a point where you want to stabilize it, you stabilize and say, right, that's fixed, maybe then move on and do another one somewhere else. So just a few lessons. These things that we've picked up along the way. Firstly, this requirements definition process is very important. It's very easy for us, especially if we like making maps, to say, oh yeah, well what they want is this, and of course it would be really useful if they had that data, and that's all fine. But we need to go that process. We find had to go through that process with the client because we don't actually understand what it is that they want. We've also found it's useful to do a sweep for useful data. One of the things we found with housing associations is that they don't necessarily always know what they've got. And there's a whole load of data which is going to be useful for us as people that are trying to make maps, like OS master map data, for example, National Land and Property Gazetteer, their own property database, which may or may not have coordinates. It's sometimes a bit hard work to dig out whether they have that stuff, if they have that stuff, who's got it, how we can get hold of it. This whole sort of data procurement stage is one that is much better to find out at the front end what you've got and what you haven't got, and do a kind of data audit, than it is to find out when you think you're just about done that actually the housing association has got master map. You would assume they hadn't, and if you knew that, you would have done the whole thing differently to start with. So kind of data audit or data sweep is a good move. Where and how to publish, how does this stuff want to get delivered? Do we put it on an external site that they can access? Do we host it for them? Do they host it for them? Does it need to go on their intranet? And of think ideally, for the kind of application we're thinking about, internet is a pretty good place to do it, because then it's part of everything rather than being stuck away somewhere. So we're moving towards trying to get it integrated into internet where technically that's possible and that's not going to cause too many obstacles. Talks about iteration, moving fast, being prepared to sort of go and see them and come back the next day with something which is different, and ask them for their views on that. Performance has been an issue for that for us, and I think it's worth bearing in mind that performance with some of these applications, and particularly when we come to JavaScript and what can be sizable JavaScript libraries, don't necessarily assume that performance is going to be as good as you need it to be. That's not to say that performance issues can't be addressed, because they can. But I think it's something that certainly we've found has been, it's not exactly tripped us up, but it's been a bigger issue than we perhaps assumed it would be. So performance optimization, and there are well-established techniques for doing that, which perhaps some of them require a level of expertise, which is really nothing about GIS. It's about web applications and JavaScript and how to deliver JavaScript-based packages effectively. All those techniques exist, but build in that sort of performance benchmarking and potential for improvements to the process.